So as I was saying, the problem on the skills check, what'd you say? Very bottom paper in that red organizer right there. We had a problem similar to this on the skills check yesterday. It says that segment ST is parallel to segment QR. Here's ST, and it's parallel to QR. So that is making similar triangles. I have two triangles in the image. There's this one up on top that's little, triangle PST, and then there's the larger triangle, triangle PQR. I'm going to go ahead and draw these two triangles separately so that it's a little bit easier for us to look at. Okay, so there's my little triangle, and there's my larger triangle. The little triangle, P, is up at the top, and then S and T are these vertices down here on the bottom. We see from the picture that segment ST has a length of 9, and segment PT has a length of 5. So I can add that to my picture of the little triangle. On the larger triangle, we still have P up at the tippy top, but now I have Q and R for the vertices down at the bottom. I see that QR is 3x plus 7, so 3x plus 7 goes down here. And then I need side PR, which it doesn't give to me, but it gives me the information I need so that I can figure it out. 16 plus x does not go all the way from P down to R. 16 plus x is just this right here. But if you look, the side of the triangle goes from P all the way down to R. So if we're going to find side PR, we need to take this 5 right here that is PT and put it together with, add it to this segment right here, TR, which is 16 plus X. And after I set up that addition, I notice that I have these two like terms right here that I can combine together. What is 5 plus 16? 21. So 21 plus X is this side right here. So from P down to R is 21 plus X. That piece right there, adding those two segments together to get that full side of the triangle, that's what was most commonly missed on the skills check yesterday. I had people putting 5 over this segment right here. Remember, you have to match up sides, so I need the whole side there. Now that I have those pieces matched up, we can set up our fractions. So corresponding would be 9 and 3x plus 7. So I can set up my fraction any way I want to, whether I put 9 on top or 3x plus 7 on top. I'm going to put 9 on top. And that would be equal to, and then I have 5 and 21 plus x. Which number has to go in my numerator because I already put 9 on top of the other one? 5 has to go on top of this fraction. So 5 over 21 plus x. And now we're going to solve this for x, which means we have to multiply by our denominators. Does it matter which denominator we multiply by first? Nope, you pick one. Let's multiply both sides by the 3x plus 7 first. If you do it to one side, you have to do the exact same thing to the other side. Over on the left, what I'm multiplying by matches my denominator perfectly. And so that means they cancel out. Nothing happens to the numerator. We don't do any distributing to the numerator on the left because that 3x plus 7 canceled out totally, so it's gone. There's nothing to distribute with over on the left-hand side. So on the left, I just have 9 remaining. Over on the right, 21 plus x does not match with what I'm multiplying by, so I can't cancel it out. This is where I distribute. If it can't cancel, then it distributes. If it cancels, it won't distribute. So I have 5 times 3x, so that'd be 15x, and 5 times 7, which would be 35, over 21 plus x. We still have to get rid of our other denominator, so we're going to multiply both sides by 21 plus x. Really important that you are putting parentheses around everybody when you're doing these multiplications. Otherwise, you're not going to distribute properly. By the way, when we distribute, we are multiplying. You never distribute and add. We always distribute and multiply. 21 plus x and 21 plus x will cancel over on the right-hand side, so my numerator remains untouched. 15x plus 35. Over on the left, there's nothing for this to cancel with, and so my 9 distributes to each piece here. It doesn't just multiply to the x or just to the 21. It multiplies to both of these pieces. So 9 times 21 is 189, plus 9 times x, which would be 9x. Then we're going to get our x's to the same side. This is adding a 9x. I want to make it cancel, so I'm going to subtract 9x so that that cancels out. But if you do it to one side, you have to do it to the other side. So I have minus 9x on both sides. Gives me 189 is equal to 6x plus 35. I want the x's all alone on one side, so I'm going to subtract 35 from both sides. Cancels out over here on the right. Got to bring my work over here now. What is 189 minus 135? 154 equals 6x. And then the last thing I have to do is divide both sides by 6. This does not come out to be a nice, pretty number. This is a repeating decimal. We get 25.6 repeating. Don't just write 25.6. That 6 is not the only thing on the screen. It's 6, 6, 6, 6, 6, 6, 6, 6, 6, 6 running off the screen. So I'm going to put the repeating sign over the 0.6. And now my answer is fully complete. All right, I will take questions over anything else you guys would like to see from the review. What else would you like for me to go over? Yes. 15? Absolutely. Let's go look at problem number 15. That is the very last problem on the entire review. So very last page, very last problem. It says that K, M, and P are all midpoints. So K is a midpoint. That means that KJ and KL are the same size. So that's something that I could write down. Segment KJ is congruent to segment KL. Or I could even write down that segment KJ is equal to half of segment JL. So that would be another thing that I could say. Said that P was also a midpoint. So if P is a midpoint, then JP is congruent to PN. So how big would PN be? 7. So that's something else that I could write. Segment PN has a length of 7. What would we call this segment right here, KP, that is joining two midpoints together? A mid-segment, yes. I can't call it a midpoint because it's not a point. But if it connects 2 points together and they're both midpoints, then that makes a mid-segment. A mid-segment is parallel to the side that it does not touch. So KP is parallel to side LN. That's something else that I can write down. Segment KP is parallel to segment LN. In addition to being parallel, that mid-segment is half as big as the side that it does not touch. So KP is half of, how big is LN? 23, so it's half of 23. We said that M was also a midpoint. So ML is congruent to MN. Which means that KM gets called a what? A mid-segment again, yes. Connects two midpoints together, so it is a mid-segment. What is PM? Also a mid-segment, yes. I happen to know that PM is 10. What's the relationship between PM and JL? It's half. PM is half of JL. So how many segments the size of PM would fit in JL? 2. So I should say 2 times 10, that's my side PM, is equal to JL. So there's something else that I can say. How big is side JN? 14. JN equals 14. How big is KM? If JN is 14, how big is KM? 7. KM equals 7. Let's look down here. If I had 2 segments the size of LM, two times LM equals 23. LN is equal to 23. You could write down LN equals 23, yes. But 2 times LM would be equal to 23. Who can come up with one more statement that we could make about this? What's one more thing we could say? KL is what? KL is 5, yes. No, sorry, close. Remember we said JL is 20, so how big is KL? 10. KL is equal to 10 because this whole side was 20 because it's twice as big as PM. Could we keep going and say other things? Yeah, I could keep going with these numbers and say what different pieces are equal to, but they only asked me for 10. I've kind of gotten a lot of them written down by going through 10. You're always welcome to look at my answer key that's posted in Canvas also to see if I had any different ones that you didn't see. What else would you guys like to look at? Number 14? Absolutely. Let's go backwards one. Number 14, find the value of x. So the first thing I notice is, do you see these two segments over here that are 17? 17 and 17. Those are congruent. And it has these right angle markings here. So that tells me that these three lines are parallel. If I have two segments that are the same size and they are perpendicular to my lines, then those lines have to be parallel. Because these two segments are congruent and my lines are parallel, that means that the opposite side is also congruent. So what do we do with things that are congruent? Set them equal to each other. So we're going to set these two equal. We had one like this on the skills check yesterday. Do 7x minus 9 is equal to 4x plus 12. That is, by the way, not the only correct way you could set this up. You could always set this up like we've done on our other problems. You could do 7x minus 9 over 17 equals 4x plus 12 over 17. You're going to get the exact same answer either way. All right, I'm going to solve this for x, so I'm going to minus 4x from both sides. That would leave me 3x minus 9 equals 12. Then I add 9 to both sides. I get 3x equals what? It's 12 plus 9. 21. And then I divide both sides by 3. How many times does 3 go into 21? 7 times. So x equals 7. Do you guys want to see it set up the other way? Okay, let's set it up the other way. In case that's the way that you would prefer to do this, we can do 7x minus 9 over 17 equals 4x plus 12 over 17. I would multiply both sides by 17. And the first thing that I notice is that what I'm multiplying by matches both of my denominators. So those are going to cancel. And so I would have 7x minus 9 equals 4x plus 12. So you could set it up like that. I had some people on the skills check yesterday set it up slightly differently, but it was still correct. They did 7x minus 9 over 4x plus 12. So they looked at this and made a fraction out of it, and then they made this into a fraction. So equals 17 over 17. What is 17 divided by 17? 1. So that would be equal to 1. And then you multiply both sides by your denominator of 4x plus 12. Cancels with my denominator there, and I get 7x minus 9 equals 4x plus 12. So no matter which way you set this up, you end up in the same spot where I started my first demonstration of this problem. What else would you guys like to look at? Yes, number 8, absolutely. Let's go look at number 8. It says DF, FG, and GD are mid-segments. So I'm going to go ahead and label those on my picture. This is a mid-segment. This is a mid-segment. And this is a mid-segment. All right. Find the value of x. So I'm looking right here, because that's where x is. What do we know about that segment right there, FD, and this side right here, which is 12? They're parallel, absolutely. So I can put my parallel markings on them. How many segments the size of FD fit in BC? 2. So 2 segments the size of FD will equal segment BC. So I'm going to do 2 times x minus 7 is equal to what? How big is side BC? 12. I take this 2 and I distribute it. Remember, when we distribute, we are multiplying. So that would give me 2x plus 14, or sorry, minus 14. 2x minus 14 equals 12. Then I would add 14 to both sides. I get 2x equals 26. And then I divide both sides by 2. And I get that x is 13. Remember, not only are mid-segments parallel to the side that they don't touch, mid-segments are half as big as the side they don't touch. Yes. Number 9? Absolutely, we can do number 9. I'm going to give just a second to make sure everybody's done copying this one down. All right, number 9. Triangle PQR has A as the midpoint of PQ and B as the midpoint of QR. Draw the triangle and its midpoints. We had a question like this yesterday on the skills check, almost exactly the same. So the first thing we're going to do is draw a triangle. We have to label the vertices. This is called triangle PQR. So one of these is P, one of these is Q, one of these is R. It does not matter where you put P, Q, and R as long as they go on the corners of the triangle. Then it says A is the midpoint of PQ. So A would have to go right here. Because it's the midpoint, PA is congruent to QA. It says B is the midpoint of QR. So here's QR. And right on that segment, we have a midpoint B. Because it's a midpoint, QB is congruent to RB. Now, it doesn't say to do this, but if I have these 2 points right here, the natural thing I want to do is connect those 2 together. So I'm going to connect those 2 points together. And that is actually the very next thing that it asks me. What do you call segment AB? It connected 2 midpoints together. So what does it get called? Mid-segment. Midpoint connected to midpoint gives you a mid-segment. And we know that this is parallel to this. I know that 2 times AB is equal to PR because AB is a mid-segment. All right, let's look at what else they tell us. It says that AP is 200. AP is this right here. That's 200. QB is 3x minus 8. 3x minus 8. And QR is x plus 30. So QR is this whole thing right here. That's x plus 30. There is one piece of information that they just gave me that I don't need to solve this problem. What do I not need? I don't need the 200. Because what do I know about segment QB and segment QR? They're not the same. QB is half. So it would take two segments the size of QB, so 2 times QB, to equal a segment the length of QR. So now I can substitute in 2 times 3x minus 8 is equal to x plus 30. I'm going to take that 2 and distribute it. Remember, we multiply when we distribute. So that would be 6x minus 16 equals x plus 30. Move my work over here. I need to get my x's to the same side, so I'm going to minus x from both sides so that I can make it cancel on the right. So that would be 5x minus 16 equals 30. Then I would add 16 to both sides. What is 30 plus 16? 46. So 5x equals 46. Then I divide both sides by 5. That means x is what? 9.2. Beautiful. Part D, down at the bottom, says that PR is 300 plus 3W. PR, 300 plus 3W. I'm going to write that down below. 300 plus 3W. And segment AB is 350. 350. What did we say the relationship was between AB and PR? Yes, 2 segments the size of AB will equal PR. So I'm going to do 2 times AB equals PR. So 2 times 350 equals 300 plus 3W. What is 2 times 350? 700. So 700 equals 300 plus 3W. I'm going to subtract 300 from both sides. What is 700 minus 300? I get 400 equals 3W. And then I divide both sides by 3. Does this come out pretty? No. Does it repeat? Yes, so we're going to have the repeating symbol over the top. What is 400 divided by 3? Yes, 133.3 repeating is equal to W. So yesterday on the skills check when I was grading that, on these 2 problems, the biggest mistake that I saw happen over and over and over was people telling me that these 2 pieces were equal instead of that I needed 2 of these to equal this. Same thing down here. I need 2 of the smaller segment to equal the bigger segment. The other thing that I saw happen a lot as I was grading the skills check is that people didn't recognize this 200 over here as extra information that you didn't need. And so they added it in different places just to try to make use of it. Sometimes they're going to give you information that you don't need, and that's okay. You can ignore it if you don't need it to solve the problem. We only have about 3 minutes left, 2.5 minutes left, which is not quite enough time for me to go over any other problems. However, this page, I have posted the answer key. So this is the page for today, Thursday 123. So you go to modules, you find Thursday 123. Scroll all the way to the bottom. I will have videos posted for all of my classes. Some of these are getting ready to go up next period. They'll all be up by the end of the day. All the way down at the very, very, very bottom is the Module 8 Test Review Answer Key. And if you click on that, you can scroll and see all of my work for all of the problems. So anything that we did not get to, you can absolutely still check your work or get some help on how to solve those problems. You guys have any questions about what happens tomorrow? Don't forget, you will turn in your test review, and then we'll take your test tomorrow, and we will start Module 9 on Monday.